Hello everyone. Today we will explain the basics of dust removal technology, particulate matter involved in air pollution control. Generally, it refers to all particles larger than molecules, but in reality, the minimum limit is 0.01 micrometers. Particles present in a stacked state of powder, usually referred to as dust. This chapter mainly explains the particle size of particles, distribution and other characteristics, method for expressing the performance of dust removal devices. Finally, for dust particles, aerodynamics in various force fields. A brief introduction was given to the 5 levels of behavior, separation, and precipitation, studying the physical characteristics of dust. These physical properties are used to study particle separation, mechanism of sedimentation and capture, the basis for selecting and designing dust removal devices. Mainly explained to everyone from 3 aspects: particle size, the physical properties of dust, and the performance of purification devices. Different particle sizes have different physical and chemical properties. Significant impact on the performance of dust devices. When observing with a microscope, using 3 methods: directional diameter, ferrite diameter, particles in the projection diagram, maximum projection length in the same direction, directional area equal diameter, also known as Martin diameter, on the projection map, in the same direction, the length of the line segment that bisects the projected area of particles, the diameter of the projected area, also known as the Huo diameter, the diameter of a circle equal to the projected area of a particle, according to the analysis dF greater than dA greater than dm. When measuring by sieving method, sieve diameter, the width of the smallest square sieve hole that particles can pass through. When measuring with light scattering method, equal volume diameter, the diameter of a sphere equal to the diameter of a particle. Determination of Stokes diameter using sedimentation method. The density of particles in the same fluid is the same. The diameter of a sphere with an equal settling velocity. Aerodynamics. Equivalent diameter. The settling velocity of particles in the air is equal to equal unit density. The diameter of a sphere. This is the most widely used dust removal technology. Since the outbreak of COVID-19, can the virus be transmitted through aerosols, has always been one of the focuses of academic attention. May 2020, Nature magazine, an international top journal, published the research results of the University of Hong Kong team. They conducted experiments on the golden hamster animal model. Put a hamster that has been infected with COVID-19 and uninfected golden hamsters conduct aerosol contact. The results indicate that COVID-19 can be transmitted through aerosols. Infect the previously uninfected golden hamster. Novel coronavirus. What are the atmospheric aerosols in the experiment? Particle size, density and properties of dust. All the content to be introduced in this lesson, except for shape and size. Dust also has many different physical and chemical properties. Design and operation of dust removal and purification system. To a large extent, determine the physical and chemical properties of dust is the basic parameters of the gas selected appropriately. Therefore, fully utilize the favorable dust properties for the dust removal process, or take certain measures. Changing the different properties of dust in the dust removal process can effectively improve the dust purification effect. Ensure reliable equipment operation. Now we will investigate the main physical properties of dust. Density of dust, wettability, conductivity, angle of repose, adhesion, and explosiveness, etc. Provide a brief introduction separately. The density of dust is divided into true density and bulk density. Due to uneven surface of dust particles, there are gaps inside. Therefore, dust particles adsorb a certain amount of air on the surface and inside. Try to remove the air adsorbed on the surface and inside of the dust particles. After exclusion, the measured density of the dust itself, the true density of dust, use use ρ P represents dust formed by solid grinding before surface oxidation. Its true density is the same as the density of the master batch. The true density of dust is widely used in ventilation and dust removal. It has a significant impact on the mechanical separation process. The true density of dust is high, easy to separate dust in a naturally accumulated state due to the presence of voids between the dust. Therefore, its overall density is smaller than the true density of dust. Will include dust particle rooms. Dust density within the gas space, called packing density. Use ρ B represents. The bulk density is mainly used for the volume of storage bins or ash hoppers. Design of pneumatic conveying of dust. Volume of space between dust particles. Ratio to the total volume of dust containing space, called porosity. The true density of dust. ρ The relationship between P and packing density is as shown in the following figure. 2. Specific surface area. Specific surface area refers to the unit volume or mass, the surface area of dust. The larger the specific surface area of dust, reduced wettability, enhanced adhesion, increased cohesion, increased conveying resistance of processing equipment. Most of the smoke and dust. Specific surface area at 1,000 square centimeters per gram, between 10,000 square centimeters per gram. 3. Moisture content and wettability of dust. Moisture content refers to mass of moisture contained in dust, ratio to total dust mass. Size of dust. Moisture content will affect other physical properties of dust simultaneously related to the hygroscopicity of dust. Wettability of dust. It refers to whether dust particles can adhere to each other with the liquid. The properties that are difficult to adhere to are called the wettability of dust. When solid particles come into contact with liquids, if the contact surface can expand and attach to each other, it can moisten. If the contact surface tends to shrink and cannot adhere, it cannot be wetted. Substances that are easily wetted by water are called clear water substances, while substances that are difficult to be wetted by water are called hydrophobic substances. Wettability of dust particles. Not only does it affect the particle size of dust, generation conditions, temperature, pressure, moisture content, related to surface roughness and charge properties, also related to the surface tension of the liquid, adhesion to dust particles, and its relative velocity to dust particles, etc. For sizes below 5 microns, especially dust particles below 1 micron, even clean water is difficult to wet. This is due to the large specific surface area of fine powder, strong adsorption effect on gases. There is a certain gas film on the surface of dust particles and water droplets. Therefore, only between dust particles and water droplets, when having a high relative motion speed, only in the Venturi throat can it be wetted. Certain dusts such as cement, hydrated lime, dolomite sand, etc. Although it is hydrophilic, but once they absorb water, it forms hard scale that is insoluble in water. This property of dust is generally referred to as hydraulic hardness. Due to hydraulic dust can cause dust removal equipment and pipeline structures or blockages, so it is not suitable to use a wet dust collector. The chargeability of dust. It refers to the process of dust generation and movement. Radiation, irradiation due to collision, friction, electricity, discharge, contact with charged objects, and other reasons. Almost all carry a certain amount of charge. Dust will change some of its physical properties after being charged. Cohesive adhesion and its stability in gases, etc. The harm to the human body will also increase. The charge of dust increases with temperature, increase with increasing specific surface area and decreasing water content. It's also related to its chemical composition. Specific resistance of dust. It is an important indicator of dust conductivity. For specific resistance, ρ express specific resistance of dust, not only related to the conductivity supported by dust particles and the looseness associated with the accumulation of particulate matter. Moisture content is related to factors such as temperature, and it also interacts with the carrier. The presence of conductive gases is related to dust conductive mechanism, depends on the temperature and composition of the dust gas. The most suitable specific resistance for electrostatic precipitator supply is 10 to the power of 4 to 5 times 10 to the power of 10 ohms centimeters. From this picture, we can see that this picture shows the relationship between dust temperature and specific resistance. So it can be seen that at high temperatures, especially above 200 degrees Celsius temperature rise, the thermal vaporization of electrons occurs inside the dust, reduce the volume-specific resistance. At low temperatures, especially below 100 degrees Celsius temperature rise, reduction of moisture adsorbed on the dust surface, increase surface-specific resistance. 5. Rest angle and sliding angle of dust. Dust to funnel, continuously falling onto a horizontal surface stacked into a cone. The angle between the generatrix of a cone and the horizontal plane, known as the resting angle of the dust, also known as angle of repose, stacking angle, etc. Sliding angle of dust. It refers to dust naturally stacked on a smooth surface. When tilting with a smooth plate, the dust on the flat plate begins to slide. Plate inclination angle, usually 40 to 55 degrees. The repose angle and sliding angle of dust. It is an important indicator for evaluating the fluidity of dust. Dust with a small resting angle has good fluidity, while dust with a large resting angle has poor fluidity. The repose angle and sliding angle of dust. Design the taper of the dust collector hopper or hopper. Important basis for the slope of dust removal or ash conveying pipelines. For the same type of dust. Large particle size, nearly spherical, smooth surface, low moisture content, reduced resting angle. Usually around 35 degrees to 55 degrees. Adhesion of dust. It refers to the mutual adhesion between dust particles. The possibility of dust adhering to the surface of the device wall. Dust particles agglomerate and become larger due to mutual adhesion. Beneficial to improving the supply efficiency of the dust collector. But the adhesion of dust to the wall can cause blockage of devices and pipelines. Fine particles with irregular shape. Surface roughness. When the moisture content is high, the wettability is good, and the charge is high, easy to produce adhesion phenomenon. In addition, it is also associated with powder, the speed at which dust moves with the airflow, and the roughness of the wall surface. Explosive properties of dust in enclosed spaces. Combustible suspension. The combustion of dust is only within a certain concentration range will cause a chemical explosion. Concentration range that can cause an explosion. It's called explosion limit. The highest concentration that causes an explosion is called the upper explosion limit. The lowest concentration is called the lower explosive limit. Below the lower explosive concentration limit or combustion above the upper limit of explosive concentration all belong to normal safe combustion. There won't be an explosion due to the high upper explosive limit concentration of most dust. In most cases, this concentration cannot be reached. Therefore, the upper explosion limit concentration of dust has no practical significance. Some dust such as magnesium powder, calcium carbide powder, contact with water can cause spontaneous combustion or explosion. Call this dust explosive dust. Wet dust removal cannot be used for this type of dust. Some dust, such as sulfur ore, coal dust, etc. When a certain concentration is reached in the air, high temperature friction, vibration, and collision outside and under the action of discharge sparks, etc., can cause an explosion. These dusts are also known as explosive dust. Some dusts come into contact or mix with each other. Mixing of bromine and phosphorus, zinc powder and magnesium powder in contact. It can also cause an explosion. Performance of purification equipment. The performance indicators of dust collectors include two aspects. One is the technical indicators, for example, processor capacity, purification efficiency, pressure loss. The second is economic indicators, equipment cost, operation cost, and land occupation. The processing capacity of the first dusty gas. Using this formula, the processing capacity of dusty gas Q is equal to half of Q1. Add Q2. Q1 refers to the inlet gas of the dust collector. Volume flow rate under standard state. Q2 refers to the outlet gas of the dust collector. Volume flow rate under standard state. The air leakage rate of the dust collector is equal to Q2 minus Q1 before dividing. Multiply Q1 by 100%. Secondary dust removal efficiency. The total dust removal efficiency refers to the total dust removal efficiency, quality of dust captured by dust collectors, percentage of dust mass entering the dust collector. Use ETA express. If the gas flow rate at the inlet of the dust collector is Q1, the inflow of dust is G1. Take care, their unit gas flow rate is cubic meters per second. Inflow rate is grams per second. Gas dust concentration C1 grams per cubic meter. The gas flow rate at the outlet is Q2. The dust outflow is G2. Gas dust concentration C2. The dust collected by the dust collector is G3. The overall dust removal efficiency can be represented by the following figure. For efficient dust removal devices, bag filter dust removal efficiency reaches over 99%. If expressed as 99.9% or 99.99%, not only is it a bit clumsy, and in expressing the differences in the performance of dust collectors, it's not obvious either. Therefore, sometimes the throughput rate P is used to represent the performance of the device. It refers to within the same time frame. Amount of dust discharged from the dust removal device, ratio to inlet dust volume, as shown in the following figure. For example, the dust removal efficiency of a dust collector ETA equal to 99%. The pass rate P is 1%. Of another dust collector ETA 99.9%. P is equal to 0.1%. The pass rate of the former is 10 times higher than that of the latter. In actual engineering, some needs integrate two or more different forms of dust collectors connected for use, forming a two-stage or multi-stage dust removal system. Dust removal efficiency of dust removal device ETA both refer to certain operating conditions. The total dust removal efficiency of a dust collector for a certain type of dust, but under the same operating conditions, the same dust collector. Dust removal efficiency for dust with different particle size distributions. It's different, therefore, to represent the relationship between dust removal efficiency and dust particle size. Propose the concept of graded dust removal efficiency. Classification dust removal efficiency, abbreviated as classification efficiency, refers to the effect of a dust collector on a certain particle size P, particle size interval, or particle size interval P. Dust removal efficiency of internal dust. So ETA I represents pressure loss of the third dust removal device. This formula represents the pressure loss of the dust removal device. You can see pressure loss and resistance coefficient of purification device. Density of gas. It is related to the inlet gas flow rate of the device. Good classmates, that's all for this class. Thank you all.